Dear students, as part of the lab curriculum, today we are doing Stephen's law experiment. Okay. In this experiment, we are verifying Stephen's 4 power law. In the sense, what we are verifying in the sense, maybe you know that Stephen's law states that uh, the power radiated, E stands for here actually the power, since we are used watt, the power radiated per unit area is directly proportional to temperature to the power of 4. Okay, it's actually absolute temperature. So to equate this equation, no, Stephens has kept his one of the constant that is called, we call this one as Stephen constant. So we can say that the power radiated per unit area is equal to sigma times t to the power of 4 here. Okay, whereas the Stephen constant value is happens to be 5.67 into 10 to the power of minus 8 watt per meter square Kelvin to the power of 4. Okay, here 4 is the Stephen index, whatever that 4 is there, no, that is called Stephen index. Here using electrical method, we try to find out the Stephen index that is nothing but 4. In case if it happens to be, while you are doing the experiment, if happens to be, if you get 4 as a Stephen index, so that straight away we can say we have verified the Stephen's law. Okay, for that we are using electrical method. So what is this electrical method in the sense, see, you can able to see that it's a Ohm's law based experiment. So Ohm's law based experiment means nothing but it contains power supply, ammeter, voltmeter, as well as the device where you need to connect. You know how to connect Ohm's law. Okay, like that electrical device and that ammeter, they comes along in series with that power supply, and the voltmeter wherever you want to measure the voltage. You know, say for example, I want to measure the voltage across this bulb. You can able to see this bulb, no? Here the bulb, we are treating this one as black body. I'll explain later why we can treat this bulb as black body. Okay, so you can able to see that filament here. Okay, so here the filament is radiating the energy here, so that we are treating this one as a black body. We'll come to that later, don't worry. Okay, so and we need to connect voltmeter across this, and anyway, while we are doing the experiment, like how to do it, all these things we'll learn. So if it comes to like why we are using electrical method, so if you see that here, we know power is equal to V into Y, voltage into like current. So and again, we know the power. In case if I know the voltage across the bulb and what is the current passing through that bulb, I can come to know what is the power we are supplying to that bulb. Okay, so and we are supplying that power, electrical power, and that electrical power in this bulb is converting into like light energy, because it is converting into heat energy, since very high heat energy is created there, very high temperature, it start emitting that radiation. So at the end you can say that electrical power is converted into radiation. Maybe it contains thermal radiation, visible radiation, all sort it have. Okay, so here whatever the power you supply, since the power won't get heated up in the sense, almost it will reach something like steady state. Like once it start glowing, no, it start glowing with the same intensity. So whatever the power you supplied is dissipating out. So that is what the black body, no, like it can emit out all the radiation, isn't it? No, like how much power it can absorb, the same amount of power it can dissipate. So because of that, we are treating this bulb as a black body. Okay, by treating this bulb as a black body, that we need to verify this one. So here power is equal to what? Where is that power? Yeah, power is equal to V into I, and then we know that resistance is directly proportional to temperature, isn't it? No, so these two are directly proportional. Temperature coefficient of resistance of a conductor, you know that. Okay, so I can say resistance is directly proportional to temperature. So since resistance is directly proportional to temperature, now if I measure the resistance, indirectly I am measuring the temperature. So the temperature is connected. We know the power, what power we are supplied. We can connect this one to what? Resistance. So if you want, you can write something like power is proportional to, like that you can write if you want, power proportional to R to the power of 4, like that. Okay, so this is the one. So in case if we equal convert it to the log, so you can say log P, I'll make it some constant sigma is there, no, some constant, plus here say for example power is equal to k times r to the power of 4, like that, where k is a constant, like that. So that is equal to log p is equal to k plus 4 log r, sorry, 4 log r. So this is the equation. Okay, if you want you can put this one as some constant of proportionality. Here this 4 in case log p along the y-axis, okay, and you can take it as this is mx plus c, that is equal to, so y is equal to mx plus c. That means along the y-axis we are plotting log p power whatever we measured using that electrical experiment, so using base law circuit experiment, and log r along the x-axis, means basically the graph will be like this. So log r versus log p, we get a straight line because it's a straight line equation, y is equal to mx plus c equation. So and whatever the slope you measured, no, if slope happens to be equal to what is that equation it is telling? Log p is equal to k plus, this is anyway y-intercept, we are not concentrating on that, we are concentrating on this 4. Okay, if the slope happens to be 4 in this graph, so I can say that the Stefan's law is verified. That's the theory behind this experiment. Okay, then how to do this experiment? To do this experiment we have to connect Ohm's law based experiment, isn't it? No. See here we have a power supply, isn't it? No, DC power supply, and this is the device, what you bulb is the device what you connect. See power supply, this one is an ammeter, and device all are connected in series. Okay, maybe here we are not connecting any resistance box, this is connected because to protect this, in case unknowingly if you rotate and if you pass very high voltage, there is a chance that it can burn out. To protect that we are using resistance coil here. Okay, so this is nothing to do with an experiment. So power supply, ammeter, and then bulb, the device where you want to measure current through and voltage across, that is connected in series, and voltmeter is connected in parallel to that bulb. Okay, so this is what that Ohm's law circuit as well as Stefan's law. To perform Stefan's law experiment, this is the one, and we need to maintain polarity here, positive to positive of the ammeter, negative of the ammeter to, anyway this doesn't have a polarity because any direction you pass, no, it's a coil, no, so you need not to worry about the polarity, and other side too directly you can connect to negative. Okay, and take positive of that voltmeter, and wherein you have to connect to this side, means where you are connected negative of the ammeter, no, to that point you have to connect negative of the voltmeter, you have to connect other side. Okay, so circuit is completed. Okay, and then we need to slowly vary the voltage using that battery. As you keep varying the voltage, no, so current will change, at the same time voltage also changes. So you need to record current and voltage. So we know current and we know voltage, so V and I. So let me write I. So V and I. If you know V and I, we know the power, isn't it? No, so power is equal to, we got it. For different voltages, we want to measure current and different voltages in the battery. Okay, we have to measure voltage and the current. So we'll come to know the power. For different power, we can able to easily calculate that resistance, isn't it? No. So and we know that resistance is equal to what? V over I. So we know that. So we'll come to know the resistance. Take a log of that power and log of that R, so that we need to plot a graph. Okay, so this is to do the experiment, this is the circuit. So if it comes to real experimental part, so here we didn't use voltmeter because the power supply is given in such a way that just if you start rotating that knob, you can able to see here, if you start rotating that knob, so it's mentioned as 1.2, 2, 4, 6, 8, 10, 12 volt. See, when that knob is at extreme left, the voltage whatever it gives out from the power supply, it is a regulated power supply. Okay, so it is 1.2. So then why we need to measure the voltage? That's what we are avoiding that voltmeter to connect here, and it is 2 volt, 4 volt, 6, sorry, yeah, how much it is? 6 volt, 8, 10 and 12. Okay, for these many steps or for these many trials we are taking, 1 2 3 4 5 6 7, total 7 trials we are measuring the current. Okay, this is the power supply. This is the switch to power on to power off we have here, and we have to take out that like two, like positive and negative, that we have to connect here. And this one is ammeter. Okay, it's a DC ammeter, you can able to see it's a DC ammeter. So whatever that current it flows, no, it records, so we can able to measure it. So it can measure maximum from up to 2 ampere, 0 to 2 ampere it can measure. Okay, and anyway, this is the bulb that we want to verify Stefan's law using this bulb. So to comes to that connection, so it's a Ohm's law based. We are not using any voltmeter, very simple, all has to be connected in series. So how to connect all in series? First, maybe you can see here, I am connecting here from this point to, so let me connect what is that, from power to where we are connecting ammeter. See, positive to positive, isn't it? No, positive of the battery to positive of the milliammeter, from negative to next thing. Okay, I'll explain once and I will connect there. Negative to this bulb, and bulb ties to other side. So in this I have connected, let me take out other wires. Okay, so where should we need to connect it? This need to be connected to, again, positive of the ammeter. Then from the negative of, anyway, we have to maintain this like polarity, because it is DC power supply. Okay, so from negative it is connected here to where we have to connect bulb. Okay, bulb doesn't have any polarity. Anyway, they have given something like one is with a black, you can see, and the other one is with the red, but bulb doesn't have a polarity. You just connect here, and then other side of the bulb to power supply. Okay, so this completes the connection. So then we have to take the reading. Before we take the reading, I'll switch on all the things. Okay, this is not necessary. Anyway, it is a power. So you can able to see that it is showing, recording some voltage, and it is on already. It was on. If it is not, maybe you can switch off. See, as soon as I switch off, what is the voltage it records? 0. Okay, I'll switch on here. You can see that bulb, see here, there is a slight maybe I covered. You can able to see that what is happening. Since the voltage is very less, the heat dissipation is also very less. Okay, maybe just check out, just I'll increase the voltage to, I have not start taking the reading, just to show you people. See, now that glow increases, isn't it? No, further if you increase the voltage, further the glow increases. Means what is happening there, as you supply more and more power, the heat dissipation will be more, because of the temperature will rise. Okay, since the temperature rises, obviously what will happen, it start glowing with more brightness, or it is moving towards the higher energy. Okay, so now what you need to do is, see, you put at 1.2, check out that bulb is glowing here. Maybe for lower voltage, the Stefan's law curve, it won't get not so straight. Okay, for higher voltage only we need to do it. So, and just check out here, this need to record how much, 0.670 voltage. What did I put? 1.2. It is 1.2. It is 6.71. That I have to record here. Okay, so first trial, maybe trial first trial you can write. What is the voltage? 1.2. What is the current I got? Current I got 0.671. 0.671. Sorry, 0.671. Okay, I know the now power is equal to V I can calculate this. R is equal to V over I can calculate this. And then after that, log P value I can calculate. Log R I can calculate. Like this, we have to go for second trial. So second trial, so I have to switch over to 2. Okay, see the glow increases here. Maybe you can wait for some seconds, so that let it come to quickly. the temperature. Anyway, it responds only, but even then you can wait for maybe 5 or 10 seconds. Then you record the voltage for 2 volt. Now it is 0.824 or 825. You can take 824. It's fluctuating. 0.824 you can take. So write down. Second trial, voltage is 2 volt. 0.824. Remaining you can calculate. Okay. Same way, maybe 4. See, now the glowness increases, isn't it? Now the brightness increases. So I set here 4. So what is the current? 1.113. Let me record that. Okay, sorry, this is how much? 4 voltage, 1.113. Okay. So next, I'll keep it to 6 volt. See, even more brightness. Okay, 1.380. Voltage is now 6. It's a fourth trial. 1.378. Okay. So next you switch over to 8 volt. Yeah, so bright now. Okay. So now voltage given to that bulb is 8 volt. You can able to see here. Voltage given is 8 volt. And what is the corresponding current? 1.621. Okay. And fifth trial, voltage 8 volt. And what is the corresponding current? 1.620. Okay. So another 2 trials left out for us now. So I have kept it in 10. Even it's going to start glowing with high brightness. Okay. See, as voltage increases, so heat also increases. So it is giving more and more brightness because it is moving towards a higher energy. What is the corresponding current? 1.836. Now 10 volt, sixth trial. What is the current? 1.835. Okay. So it's the last one. Let me keep it at. Now where it is? It is at 12. Okay. It is at 12 volt. So it is too bright now. Okay. And then see the, oh, it's going out of scale. So we can't have it. Maximum 2. Since when I keep it at 2 volt, it is going out of scale. So this reading cannot be taken. Not possible with that meter. Maybe if you would have higher range of a meter, we would have taken that. So these are all the readings. That's it. Only 6 reading I can able to get it. So with this, further we need to calculate what? Power and resistance, log P, log R. You need to plot a graph in the graph sheet. Log P versus log R. You need to take appropriate scale in such a way that it should fit neatly inside that complete graph sheet. Okay, if you choose bigger scale, maybe sometimes it may go out that readings. Smaller scale, it look too small. So appropriately you need to choose a scale and you need to plot a graph, log P versus log R, and then you need to measure the slope. Okay, if the slope happens to be 4, then you can say the value of Stefan's index is equal to so much, hence verified. Which one is verified? Stefan's law is verified, like that we can mention. Okay, is it clear now? Thank you.